one thing you probably hadn't considered is that every time you plot a point, you're actually carving out a right triangle. So if I was going to plot the point 3, 4, you know that what you do is you go 3 to the right, start at the origin, go 3 to the right, and go 4 north. So if we were going to plot that point, it would be right over here, having carved out this particular right triangle. This particular right triangle, that's a right angle. This is why these are called rectangular coordinates. You always form the sides of a rectangle. So what I can ask you then is how far this point is from the origin. And since you have a right triangle, you know that it will be 5 units from the origin. Even if you were going to plot the ordered pair -3, -4, you know you'd go back 3, down 4, so you'd have a point right over here, back 3, down 4. So if you carve out your path that you follow when you're plotting the point, those are the legs of the right triangle. And we would say that the length of the hypotenuse is still 5. Length is always positive. If I wanted to plot the point with coordinates, it might get a little bit trickier. Let's say 3, 6. In fact, let's make that -3, 6. -3, 6. 1, 2, 3, 4, 5, 6. So we go back 3 and up 6. So that distance is still 3, and the distance we go north is still 6. And I'm looking for the distance from the origin. Well, that gets just it's not a triple, so I have to use the Pythagorean theorem. C squared is going to be 3 squared plus 6 squared, which is going to be 9 plus 36, which is going to be 45. And then I'll need to take the square root of both sides, obviously. So the c squared is 45, so c is going to be the square root of 45, which we know is going to be 3 root 5. This distance on a plane gets a little bit trickier if you're not using the origin. So if we wanted to find the distance between the ordered pair 3, 1, and the ordered pair, let's see, this is 8, 6. To get from one point to another, you know that you always have to kind of not cross over any lines. So what we could do is, we know that we would go over, let's see, this is 1, 2, 3, 4, 5 to the right, and then we'd be going 1, 2, 3, 4, 5 north. So the distance between those 2 points still involves the Pythagorean theorem. And I would write c squared equals 5 squared plus 5 squared, which is going to give us 25 plus 25, so c squared is 50. And then if I take the square root of both sides, the square root of 50, we know 25 comes out. So that is 5 times the square root of 2. And we will formalize this very shortly. This becomes a huge formula in mathematics, and it's going to give rise to every conic section. And we would say the distance between 2 points is, we're going to call this the change in x squared, which is what we have over here, plus the change in y squared, which is what we have over here. And the reason we take the square root is, again, because of the Pythagorean theorem.